All right, guys, so here we go. We have not had class in a week. Actually, it's been exactly a week since we last had class. So, to try and compensate for that 1 week of missed lecture, I tried to put 2 lessons into one. Relax. It's not, a typical lesson is 30 to 40 minutes, and, 2 lessons would have been 80 minutes. I condensed it into one lesson here. It shouldn't take, it'll be about average. So if I didn't even mention this, you probably wouldn't even know. So let's get started, and hopefully it won't be too bad because we kind of already started doing area under curves. So maybe area under curves or between curves won't be a big issue. Okay, so here we go. Note 32. Let's chat about average velocity of a function. Why am I starting with average velocity? Because this is something you guys have previous experience with. When you were in physics, this is all you were able to do because you weren't able to find instantaneous velocity. When you were in physics, how would you figure out average velocity? Perfect. Displacement over the change in time. Yes or no? All right. What have we learned in calculus? How do I get displacement in calculus? No, that's distance. I'm fine. How do I get displacement? I get the area under what curve? Yeah. How do I find displacement with calculus? If I give you, yeah, under the velocity curve, I integrate from A to B. Yeah, we're rusty, guys. We're rusty. This is what happens when we don't have any cal for a week. You integrate from A to B of your velocity curve. If I put absolute value on the velocity, then that displacement turns into distance. So here's how you find average velocity with calculus. Usually they write it like this: b minus a integral a to b v of t dt. Relax. You're not a robot. This is the same as this. Bless you. It's the same, guys. I'm running out of space, so I'm going to write it over here. I could have written it like this. I could have written it a to b of v of t dt. This is displacement divided by, what's the change in time? B minus a. Do you guys see that? So that b minus a, I can just put 1 over b minus a, and that's the same thing as this expression divided by b minus a. Cool or not cool? Okay, this is how you find average velocity. So now here's the question. Now, what if I want to change? What if I change it and I say I want the average f? So I'm going to write average f. Well, look. If I found the average velocity and it was 1 over b minus a integral from a to b of v of t, what do you think my formula is going to look like when I find average f? Trav, I don't know what you're talking about. I want a formula for average f. I want you to notice average velocity, 1 over b minus a, and I integrated velocity. So, yes, 1 over b minus a integral a to b of f of t or f of x. It doesn't matter what letter you use. Remember, it's a dummy variable. You will see many textbooks that say this value, this formula, and this is how you find average value of f. I don't want you to be a robot. We derived it. Chav, how did we derive it? Well, we didn't derive it directly, but we derived it from finding average velocity. You know that average velocity is displacement divided by time. We know that displacement was just the integral from a to b of velocity, and then the change in time is just b minus a. So 1 over b minus a integral a to b of v of t is average velocity. So average f, 1 over b minus a to b of f of x. Cool or not cool? Average acceleration, 1 over b minus a integral from a to b of acceleration. Average r, 1 over b minus a integral from a to b of whatever r is, integral of r of x dx, r of t dt. Does that make sense, guys? So this, we're not robots. Do we know why it is this value? Like why this formula is this formula? Okay, Espinosa, you okay? Okay, remember, guys. Okay, here we go. Let's see if we can do it. This problem, I want to give credit. I believe this problem is coming from the UH quiz average area or average value, one of those two quizzes, which is coming up next. Example 1, find the average value of the function. So I have a function, x cubed on the interval -2 to 2, and determine number c on this interval, for which f of c is equal to the average value. Okay, there's a lot of words there. Let's slow down. Let's see if first you can use, what is that word that you guys use when your intuition? Your intuition when you guys, let's see if we can use our intuition to find the average value of this function without any formulas. F of x equals x cubed. Do we know how that function looks like? Everyone took algebra 2, so we should. How does it look like? What? Tell me. Like, yeah, you guys are just doing hand gestures. Does it look like this? Does it look like this? Does it look like that? Okay, there we go. So, here we go. I'm not going to draw it perfect. It doesn't have to be perfect. So check it out. So you guys told me it looks something like this. Yes or no? Yeah. All right. Here's like -2. Here's like 2. Use your intuition. What do you think the average value of this area from -2 to 2 is? Yes. How did you do that so fast with your super smart intuition? I'm sorry, guys. I'm not. Because they cancel out. You know that x cubed is an odd function, so I have just the same amount of area above the x-axis as below the x-axis. Yes or no? Yes. So some of you sometimes are robots, and you guys will be like, oh, Chavez taught me that average f is this, and I'm going to go ahead and you go 1/2 minus -2 integral -2 to 2 of x cubed dx, and which is correct. And you go, okay, well, that's 1/4. And then antiderivative of x cubed is x to the 4/4, -2 to 2. And then check it out. That 1/4, I'm going to put it here on the outside. All I'm doing is upper minus lower. 2 to the 4th over 4 minus -2 to the 4th over 4. Let's see, 1/4. 2 to the 4th. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 divided by 4 is a 4. Minus -2 to the 4th is again going to be 16. 16 divided by 4 is a 4. What's 4 minus 4? And 0 times 1/4? Are you shocked that you got 0? No. Some of you will do that. And did you have to do all that work? No. As long as you recognize that x cubed is an odd function. And this, look, -2 to 0 is the same horizontal displacement as 0 to 2. Well, the same distance, right? Magnitude. So those areas are going to cancel out. Does that make sense, guys? Cool. Now, it also tells me determine the number c, so that just means some x value, on this interval which f of c is equal to the average value. So they want to know, where is f of c, which is c to the 3rd power, equal to 0? Well, the only time, pretty much what this means, guys, in case you're like, what's with all the letters, Travis? When does this function hit the average value of 0? It hits it at the origin. So, well, they said the letter c, so let's put at c equals 0. C is some specific x value. The number c is 0. Does that make sense, guys? What's up, Ian? Oh, I did antiderivative of x cubed. Add 1 and divide by that number. If I take the derivative of x to the 4th over 4, I better get x cubed. That's how you find antiderivative of a polynomial. So add 1, divide by that number. So practice your delta and practice your UH. Take care of that quiz, miss. Sorry, I didn't mean to call you out like that. All right, here we go. Let's see if we can do an application problem. An observer measures the outside temperature every hour from noon until midnight, recording the temperatures in the following table. So here it is. And it says, use trapezoidal to help you out. What is the average temperature for the 12-hour period? Okay, so someone tell me, why can't I just add them up and then just divide by how many? Isn't that how you find your average grade? Why can't I do that? Yeah, this is a continuous function. There's a temperature between noon and 1 in the morning, or what is this? What does the S start? Yeah, it starts at noon. So not 1 in the morning, 1 p.m. It's continuous, guys. 1 to 2. It's always changing or technically, and it's a continuous function all the time. Like, does that make sense? When you talk about discrete grades, like I got a 25, a 50, 75, like those are just like they're just random. Like, what I'm trying to say is, if you have a 25, you got a 50, and you got a 75, I know those are horrible grades, but that's your grade on quiz 1, your grade on quiz 2, your grade on quiz 3. These are just random 3. It's not a continuous function. You just got 3 random points. If you want to find the average of this, yeah, add them up, divide by 3. But these are not just random points. You have a continuous function. Temperature is continuous on your temperature time graph. Is that making sense? So to find the average temperature, you got to do 1 over b minus a integral of your temperature, just like we did average velocity. Is this making sense? You can be honest and say no. Okay. So remember, okay, let the units help you out in case you're like, the units for this, guys, is just going to be a degree. So we're just doing average temperature. So you're like, Chav, I still don't understand what's going on. So here's your time in, what is this, hours? And here's your temperature in degrees Celsius, I think, right? Or degrees Fahrenheit. No, those are way too warm to be Celsius. Degrees Fahrenheit. All right. I know what you're thinking. You're like, Chav, how is that going to give me just degrees Fahrenheit? Well, when you find area under this curve, it's going to be degrees Fahrenheit times hours, right? But remember, we're dividing by b minus a. B minus a is the difference in time. I'm dividing by hours, and then look, hours cancel out, and you just get degrees Fahrenheit. Does that make sense? Chav, I don't understand what you're talking about. 1 over b minus a integral from a to b of this temperature. See, so this here, that's area under the curve. That will give us degrees Fahrenheit hours. And then you see this b minus a? Isn't that just like how much time changed? That's in hours, guys. This is in hours. And it's 1 over it, so it's like dividing. Degrees Fahrenheit times hours divided by hours. Hours cancel out. You just get degrees Fahrenheit. Cool or not cool? Okay. So here we go. Do I got enough space? Oh, I don't. Let me erase some of this, guys. Sorry if I went off on a tangent there. I went off on a tangent. Okay. Hopefully it all made sense. I hope. If it didn't, please swing by and we'll have a chat on it. All right. So here's what I'm doing. No, you can leave it. If you have enough space, you can leave it. You don't have to erase anything. All right, here's what I'm doing. 1 over, I'm doing the difference between noon and midnight. The difference between noon and midnight is 12. Integral from noon. So I'm just going to call that 0, because this is like a 0, all the way to 12 of temperature. I'm going to call it T, capital T of X, dx. Are we still okay? All right. Are these values spaced out by 1s? That's my delta x, which is going to be my h of the trapezoids. I'm just using my trapezoidal formula. You don't have to. You can do it one at a time, but this is way easier. So here we go. That 1/12 is this 1/12. So here we go. I'm going to write, let's see, 1 over 2, giant parenthesis. Then I'm going to write, that's my first value. So I'm going to write 63. And I guess you don't need a parenthesis there, but I'm getting ready to put plus. What do I write now? 2, good job, times 65 plus I'm going to put plus dot dot dot. That means continue. The same pattern all the way. I'm going to continue it right here. 2 times 58 plus 55. Close this parenthesis. Close the bracket. Someone do me a favor and figure out what's inside this bracket here. Yeah, guys, try it out, guys, because you guys are going to be taking this test. Okay, here we go. I'll do it. But you guys try it out too, guys. Oh, because that calculator might be an old operating system, so it might not have. Yeah, that's why I'm telling you to use your calculator. All right. Here's my 1/2. Open parenthesis. 63. So someone help me up with these numbers. 63 plus 2 times 65 plus 2 times plus 2 times. Wasn't it 67? All right. Plus 2 times. Plus.
No, wait.
Guys.
Oh my God. No. Stop. It's 70. 70.
Okay. Plus 2 times.
69.
Plus 2 times. Plus 2 times. Plus
2 times 65. Plus 2 times 64. Plus 2 times 62. Plus 2 times 58. And then just plus 55.
and then close the parenthesis. If I did everything correct, I got 782. Okay. Now, all right, guys, focus, focus, focus. Now, take that 782 and divide it by 12. Either divide it by 12 or multiply it by 1/12. It's the same thing. So there it is. You could also have done 782 times. If you don't like dividing, you could have done this. You put a 1 on the top, put a 12 on the bottom. You should get the same answer. If you don't, okay, push math, number 2 decimal, and there it is. Did we get the same thing? 65.166666667. 65.1666667 degrees Fahrenheit. That is the average temperature. Okay. Guys, make sure you're not robots. Sometimes I'll see you guys that you guys will tell me that the average temperature, you guys are going so fast, and you go, don't write this down, just listen. You tell me the average temperature that I got, you tell me all this beautiful, and I'm like, that's correct, and then you show me this line, and I'm like, that's correct also, and then you tell me the average temperature is 43 degrees Fahrenheit. And you just move on and don't even look at it again. Is that possible to have an average temperature of 43? No, I'm just making it up because you guys are robots. Guys, it's not possible. Look, that's 63. I never go in the 40s. How is it possible that your average temperature is a temperature that you're never... Intermediate value theorem, guys. You can't be a number outside of your range here. Does that make sense? Sometimes you guys will tell me that the average temperature was 82 degrees Fahrenheit. Look, I never hit higher than 70. How can I be 82 degrees? Is this making sense? Yeah, what I'm trying to say is don't be a robot. It's not, it was never that, guys. So look, 65.166. Yeah, I can see how it could be that's the average temperature. Okay. Here we go. This question. Okay, guys, focus. This question, I think this was on your exam, your mock exam that you took recently. 44% of the test takers got this question correct. Do you guys want to give this one a shot and see if you guys can get that question correct? All right, try it out, and it's okay if you get it wrong, guys. Look, this is your first time doing it. Try it out, miss. That was good coffee. Yeah. I need to, miss. I haven't been sleeping this week.
I don't think I got the right. No, I got an answer, but it's not there. I thought I was doing it.
Have faith in yourself. Maybe you did do it right.
No, because I got an answer that's not there. So.
What's the antiderivative of 1 over x?
Oh.
ln. Yeah, you're right.
Oh. No, I was talking about.
You got an answer?
I didn't think about it.
All right, I'm gonna get started, guys. You should be close to finishing. Let's see how tough this question was. I haven't done it. Here we go. Let f be the function defined by 1 over x. What is the average value of f? So they want me to do the topic that we just learned right now on the interval 4 to 6. Okay, let's see. I'm gonna go. I'm gonna write this first. Average, and I feel like I should have mentioned a conceptual reason. Average of f is equal to 1 over b minus a, integral from a to b of f of x dx. So first and foremost, there's my formula that I'm going to be using. They want me to find out the average between what and what? 4 and 6. So the a is 4, the b is, here we go, 1 over 6 minus 4, integral 4 to 6 of 1 over x dx. Are we okay? All right, equals, there's that, 6 minus 4 is what, just 2? There's that 1/2. I put a bracket for the 1 over x. What's the antiderivative of 1 over x? ln of x. Close my bracket, put a lower limit of 4, upper limit of 6. Are we okay so far? Yeah. All right, I come back over here, I write 1/2, and I'm going to evaluate my bracket. Fundamental theorem of calculus, I do upper minus lower. So I go ln of 6 minus ln of 4. Are we still okay? Yeah. You remember your log properties. Side note, I'll put it right here. ln of a minus ln of b is the same thing as ln of a over b, as long as b is not 0. Well, you can't be 0 because that's not part of the domain. So here we go. 1/2 ln of 6 over 4. 6 over 4 reduces to 1/2 ln of 3 over 2. I look for that. Is it in there? 44% of test takers got this right, and they had the whole year to do this question. We just started, and we already got it, hopefully. And if you didn't, it's okay. All right, real quick, go back to this real quick. I just want to make sure that you guys understand the visual. So here's what the visual is of average value. I hope we understand. So if I have a box from 0 to 3, and I'm going to say that's 5. I just went back to page 1. I'm just trying to describe. What's the average value, and I'm going to call that f of x. What's the average value of this function from 0 to 3? No, the average value, not the area. It's always 5. So because it's always 5, the average value has to be 5. If I had a curve, and I'm gonna go, I don't know. I'm just making up a curve, guys. And I told you that the area under this curve. Okay, focus, guys. Focus. Lava, focus real quick. If I told you that the area under this curve. Do you see all that in black? That's the area under the sky blue curve. If I told you that the area under this curve was 15, and I told you what's the average value of that blue curve, you would tell me that the average value of that sky blue curve is 5 because, Chav, I don't understand where you're going with this. How are you making the connection? Isn't 5 times 3, 15? And you just told me that the average value of that function of that red line, the horizontal red line, is 5. And now I'm telling you that the area under the curve of the sky blue one is also 15. And notice that I also go from 0 to 3. So the average value of that sky blue curve must also be 5 because the area is 15. And in case you're wondering, Chop, I still don't get it. Well, look at my formula here. 15 divided by 3, don't I get a 5 anyways? Yeah, so this horizontal line that's always 5 Yeah, it makes sense. It's always 5. The average value has to be 5. Well, area under that curve is 15. Look at the sky blue curve. The sky blue curve, I'm telling you, that shaded in black, I'm telling you that area is 15. I just made it up. If I tell you that the area under the sky blue curve is 15, between 0 and 3, then the average value of that sky blue curve is also, the average value is also 5. So that means all this that I shaded in black can fit under the rectangle, under that red rectangle. Does that make sense? I think there's a guided, on Delta, I think there's a guided that tries to show this. I don't know if it does a good job of showing that. I can't remember if it was Delta or if I saw it on a MATLAB program. Do you guys know what MATLAB is? M-A-T-L-A-B? M-A-T-L-A-B. Okay, for those of you that are going into math and engineering and science, this is very powerful software. It's a CAS. It's used by industry. If you become a boss with MATLAB, you will be indestructible. You will be God.
Yeah, I love that.
Okay, I'll stop. All right. Did that make sense? Yeah, you'll be an actuary like crazy. All right, here we go. Let's continue. Oh, we can't do that one yet because of USUB. All right, we have not talked about U substitution. Do you want to know? Do you want? Okay. Remind me when we do USUB, and we will go to this example. We haven't done USUB. It's just another tool on how to integrate. What's coming up next? Yeah. All right, here we go. This one is coming from UH. Good thing I put it in there. You guys ready? We're going to go slow. Suppose that b is greater than 0, so I have a positive number. And the average value of f of x equals 5x minus 3 on 0 to b is 1/4. Find the value of b. Guys, this is algebra with a little bit of calculus. So we know, look, this is very simple. Look, watch, relax. Average of f. So make sure you get into the habit of writing it like this. 1 over b minus a, integral from a to b of f of x dx. Are we okay with that? Yeah. Okay, here we go. 1 over b minus 0, because I want you to see where everything's coming from. Integral from 0 to b of 5x minus 3 dx. And they tell me that the average value is what? 1/4. Here's the only calculus that there essentially is on this. Find the value of b. Okay. You guys ready? Yeah. Okay, I'm not doing anything crazy. I'm going to get rid of this statement here. That's just, well, that's 1 over b. I'll rewrite it again. 1 over b, integral 0 to b of 5x minus 3 equal dx equals 1/4. Relax, guys. This is simple. I'm going to, what I'm trying to solve for is b. I have to do an antiderivative. So before I do that, I'm going to go times b times b. So do that. And now I have this. I have integral 0 to b of 5x minus 3 dx equals b over 4. I guess I could have left it over there and distributed it, but that's fine. Are we okay so far? All right. I'm going to do antiderivative of 5x. You ready, Gian? What is the don't worry, no pressure. What is the antiderivative of 5x? So what do I do to that exponent? Right now it's a power of 1. So I'm going to, perfect, 5x squared, and then and divide by 2. Minus, what's the antiderivative of 3? Perfect, you got it, miss. Put that, because I have more than one term, I put it in a bracket there. I put a 0 on the bottom, I put a b on the top, and that equals b over 4. Are we still okay? You're done with calculus. It now turns into algebra, guys. Upper minus lower. It's very simple. Nothing crazy. Upper minus lower. I don't have to worry about the 0 because when I plug in a 0, everything zeroes out. So I'm just going to have to worry about the upper one. So I'm going to come over here, and here's what I have. 5b squared over 2 minus 3b equals b over 4. Are we okay? Yeah. Let's see. What do I want to do? I want to... That's a B. That's a B. Yeah, I'm going to multiply everything by 4 to get rid of the fractions. There's so many ways to do it here. I could have left the 1 over b here and distributed that. You know what? No, I already did it. I was gonna bring back the 1 over b, but that's fine. I'm going to multiply everything by 4. So when I do that, 2 goes into 4 how many times? I'm doing this. 2 goes into 4 twice, and 2 times 5. So I have 10b squared minus 4 times 3, 12b equals b. I'm going to move, let's see, I'm going to move this b to the left, and I'm going to solve for my 0. So I have 10b squared, and then 12b minus b is 13b. Let's see, I'm going to factor out a b. Let's see, I don't see any mistakes. Is there any mistakes that I've done? I don't see any. No, I don't see any. B, and then factored out, I see 10b minus 13, close it, equals 0. So now, so here are my b's. 1b, so I'm going to come over here. 1b is 0. I don't see that answer of 0 in there, so that's not going to be that one. Another b, so 10b minus 13 equals 0, so that means 10b equals 13, so that means b equals 13 over 10. Is that answer in there? There it is. Maybe I made that harder than it really is. Maybe someone's watching it right now on YouTube and you're like, man, Chav, you should have just distributed the 1 over b afterwards. Maybe that would have been better. I kind of like that better, but maybe. But it doesn't matter. Correct algebra is correct algebra. Cool or not cool? Okay. Here we go. This one's coming from Delta, so let me give them credit. I can tell by that graph there. Okay. Here we go. The regions A, B, C, and D in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 4, so this is 4. The area of region B is 11, so 11. The area of region C is 19, 19. And the area of region D is 13, 13. What is the average value of f on the interval -5 to 7? Okay, so I'm going to put a little dot, -5 all the way to 7. All right, I think about average value. I'm going to write average of f equals 1 over 7 minus a -5 integral -5 to 7 of f of x dx. Hopefully, now that you've written that at least 3 times, it's starting to become habit. Are we okay? I look at it and I say, okay, I can do that. This just means area under the curve, signed area, of course. And then this is just some fraction here. So 1 over, what's 7 plus 5? 7, 8, 9, 10, 11, 12. So 1/12 times area under this curve. So let's see. I'm going from -5 to 7, so I'm counting the right way. From -5 to -2, it's 11, so I'm going to put 11. Plus, from -2 to 2, it is 19, but positive or negative? Negative, so -19. I guess you could have written 11 minus 19. That's fine. And then from 2 to 7, it is 13. Close my bracket. So let's see what we got. 1/12 bracket. So let's see. 11 minus 19, that's -8. And then -8 plus 13. So 13, 8, 9, 10, 11, 12, 13. Is that 5? So 5 times 1/12, positive 5, yeah. So 5/12. This is my area. Oh, that's not my area. That is my average value. So the average value from -5 to 7, if you were to draw a horizontal line, would have been somewhere like right there. If they ask you, how often is this curve from -5 to 7, 5 over 12? It is 5 over 12, this curve, 1, 2, 3 times. Oh, actually 4 times between -5 and 7. They didn't ask you that, but if they did, does that make sense, guys? How do we feel? Okay, let's do one more here before we switch the topic. Don't worry, it's a simple topic. It's over all this that we've been doing. Which one? Yeah, don't worry. It's gonna be simple. You'll see. Example 7. Let f be the function defined by f of x equals negative 2x squared minus 3. What is the average value of f on the interval negative 1 to 1? Guys, I can't stress enough. I know you have calculators. If it's something this simple, do it by hand. Sweat. Espinosa, you okay? Sweat so we can make sure that we know how to do this by hand, guys. So they want the average value between negative 1 and 1. So here we go. Average of f, I'm going to write the formula again, equals 1 over 1 minus a negative 1 integral from negative 1 to 1 of f of x, which is negative 2x squared minus 3 dx. By the way, when you're writing these, you don't have to necessarily put a parenthesis on your f of x. Some textbooks will not put parentheses. It's understood that the dx is the end. Are we still okay? All right, so here we go. I get 1/2 because 1 plus 1 is 2. And I'm about to do the antiderivative. What's the antiderivative of negative 2x squared? Perfect. You can say 2/3 and write 2/3. I like to write 2x cubed over 3. Whatever your habit is, do it. Not a big deal. Minus, what's antiderivative of 3? 3x, close it from negative 1 to 1. Are we okay? Okay. Leave the half alone. Bracket, I'm doing upper minus lower. Giant parenthesis. I'm plugging in a 1. So 1 times anything is itself, right? So 2/3 minus 3, close my parenthesis, that's a 1. Minus, giant parenthesis again. Negative 1 raised to the 3rd power is going to stay negative. What's negative times a negative? Positive, so turn that into a 2/3. And then negative times the negative is again a positive. Are we okay so far? All right, so here we go. I have a half still. Bracket, let's see. Can we do this by hand? Don't try not to use a calculator, guys. This 3 is the same thing as 9 over 3. I'm just getting a common denominator. That 3 is the same thing as 9 over 3. I just multiplied the 3 by 3. Are we okay with that? Okay. So negative 2 minus 9, that is negative 11 over 3 minus, and then again, this is going to be the same thing. 9 plus 2 is 11, so it's going to be minus 11 over 3. Do we have any issues with that right there, guys? Okay. I'm gonna add these up. I guess I'm subtracting technically, but add up the 11s, keep the sign. So here's my half. Bracket 11 plus 11 is 22. Keep the sign. It's still negative. 22 over 3. Close it. Are we still okay? Okay. And then positive times a negative is a negative. So my average value, so I'm going to put a negative on the outside. And here's how I would do this. You can say negative 22 over 6, but then that reduces. I would do it like this, guys. 2 goes into 22 11 times. See? And it becomes simple. Negative 11 over 3. That is the average value. How do we feel? Was that tough? No, you can do it. You can do it, guys. We got this. The only thing that's stopping you is practice. Guys, and I know you guys are overwhelmed, and you guys, the whole world wants you to invest time. There's movies out there that are more entertaining than doing some of these. I know. But guys, the only way you're going to get really good is to invest time. If you never invest time, you're never going to be super amazing at it. Now, there are people out there who are just magically talented. They can just view it and then just be good at it. But most people have to practice, guys. LeBron James had to practice to get where he is. Michael Jordan had to practice to get where he is. Now, obviously, they were already blessed with skill, with the size and athleticism, but they still had to practice. Okay. How do we feel with that lesson? Do we have enough stamina and energy to do one more? Okay, don't worry. This is not, we're not doing, I did this by design. We're not doing anything crazy. All right, here we go. I'm going to draw two curves. I'm going to call that curve f of x. I'm going to call this curve g of x. I'm going to go A, B. I haven't done anything crazy. I want the area in between those curves. I want that area in burnt orange. Do you guys see that? Okay. I hope I'm going to first describe how I think you would do it, and then I'm going to tell you the fastest way. So I think you would probably do it like this. You would say, well, the curve f of x is above g of x, so I'm going to find this area first. And I know how to get that area by just doing integral from a to b of what function? F of x. So I write f of x dx. And I see that that sky blue is below that curve. And then you'd probably go, well, if I subtract this in purple, that will give me the burnt orange, won't it? So then you would probably go minus from a to b of what curve? G of x. Did that make sense to you guys? Okay. Then from looking at this, hopefully you see it and you're like, wait a minute. I remember when we did properties of integrals, f of x dx, the limits are the same. So I can just write this as one integral expression and say from a to b of f of x minus g of x. And there it is. Chav, you're missing a parenthesis. It's understood that the dx means the end, but if it makes you feel better, you can do f of x minus g of x and then whatever that is times dx. Cool or not cool? All right. Did all that make sense? Okay. What I usually tell kids or teachers, or whoever it is, whoever my population is you can always just do this, guys. So here's a curve. You can remember all it is Riemann sums. My rectangles are like this. Those are my rectangles in there, like that. Just draw a vertical line. Which one's on top? F of x. Which one's on bottom? G of x. So f of x minus g of x. That makes sense? And we can do that straightforward, right to the point. You have a whole bunch of rectangles in between those curves, and you're adding them all up. So infinity. Cool or not cool? All right. So there it is. That's it. That's all. That's it. So ready for this? We're going to go slow. We're going to go slow. Look, I have a curve. This is coming from your Demena text. Let me write Demena. Demena. It's a textbook that we have here in our school district. So I have a curve and I have another curve and I want the area in between. From what to what? 0 to power 4. So I'm going to go integral, lower limit of 0, upper limit of pi over 4. What do I write first? Secant squared. So write secant squared x. And then what do I write next? Minus sine x. If it makes you feel better, you can put them in parentheses. And then I end my integrand by writing what? Dx. You don't have to, by the way. You could have easily written it without parentheses. Some people don't like that. That's fine. But remember, that dx is like your end of your integrand there. Are we cool? And remember, this just means already that you have an infinite amount of Riemann sums. Width times height, or the width is the dx and the height is the secant squared minus sine x. Cool or not cool? All right, here we go. Can you do antiderivative? What is the antiderivative of secant squared? 10x. Chav, how do I know? Here's how you can test it. What's the derivative of tan? Secant squared. See? So you can test it. The derivative of tan is secant squared. It works. So antiderivative of secant squared must be 10x. Minus, what's the antiderivative of sine x? Cosine, is it negative or positive? What's the derivative of cosine? Negative sine. Look, there's a negative there, so that means that this must be plus cosine x. Chav, how do you test it? What's the derivative of cosine? Negative sine. So if I would have taken the derivative of that, you get that expression on the inside. Someone ask. Did someone have a question? Yeah, this can be tricky. 0 pi over 4. There's some that don't like the bracket with the 0 pi over 4, guys. I get it. It evaluated. This line means evaluate from 0 to pi over 4. But if you have more than one term, you usually put a bracket to indicate you're doing all those two things. But it's not a big deal. No points off. Relax. You're good. Okay. Are we okay so far? All right. All I'm doing now is upper minus That's all you're doing. So here we go. Bracket, giant parenthesis, tan of power of 4, a little bit of pre-calc, not even extreme, plus cosine of power of 4, close parenthesis, minus, open parenthesis, tan of 0, plus cosine of 0, close parenthesis, close bracket. Basic pre-calc, not extreme. Don't freak out. I guess I don't need the bracket anymore. What's tan of power of 4? 1. What's cosine of power of 4? Square root of 2 over 2. Minus, parenthesis. What's tan of 0? 0. Plus, what's cosine of 0? 1. When you subtract or distribute that negative, however you want to see it, the 1, 0 out, and all you're left with is... So the area between those two curves, this area here must be square root of 2 over 2. Is this making sense, guys? All right. Let's keep going. Notice we're almost done. We're going to do this one without a calculator. And we're going to do the one on the bottom with a calculator. All right, here we go. We're going to go slow. Cool or not cool? All right, I want this area. If you do your little vertical slice, you can see what's on top and what's on bottom. I mean, I know you can probably visually see it, but it's easy to see it that way. I need my limits. I need this x value here, and I need this x value here. I know that you can probably tell by looking at that graph. But you want to make sure that you're definitive. What if I didn't have that graph? How would I do it? So before I even start, this is a parabola. That's what's on top. So y equals 2 minus x squared for that one. And on the bottom one, that's my linear line. That's y equals negative x. Are we okay? All right, here we go. I'm going to find where these two lines intersect, these two equations intersect. So how do I do that? 2 minus x squared equals negative x. Do that. Cool or not cool? What are you doing? I'm finding the x values of where they intersect. Are we clear? Okay. I'm gonna move this. Ask me questions, guys. Are we okay? Okay. I'm gonna move this to the right because I like to have a positive x squared. My highest degree, I like for it to be positive. So 0 equals x squared minus x plus 2 equals 0. Oh. Yeah. No. Did I make any mistakes? Maybe I need a calculator for both.
Your x is positive because you moved it over.
Oh, this is minus 2. Thank you, guys.
Oh.
Yeah. No, you're good. You're good. Sorry. Now, yeah, we're right. Now you guys are right. Tell me again, Flotus, what these factors are.
X plus 2, x minus 1, which is x.
No, it's.
Flip.
Yeah.
I did off.
Oh, well, okay, you did the negative x to the other side, and then you factor out negative x. That's fine. X minus 2, x plus 1. Are we okay with everything so far, guys? So here are my x values. X equals 2, x equals negative 1. Before I continue, does that look like negative 1, and does this one look like 2?
Yeah.
Okay. Are we cool? All right, here we go. I go integral. What's my lower limit? Negative 1. What's my upper limit? 2. What curve is on top? 2 minus x squared. What curve is on bottom? There it is. Put a giant parenthesis like that if it makes you feel better. I think that I want to combine actually there's nothing to combine anyways. If you want to make it look prettier, so here it is, making it look prettier. We're doing this by hand. Negative 1 to 2. Minus a negative turns into a what? Positive. So I'm going to write the highest degree first, guys. Negative x squared plus x plus 2 and then dx. I don't think I've made any mistakes. Is everything clear so far? Okay. All right, here we go. Antiderivative of negative x squared. Perfect. What's antiderivative of x? Yeah. What's the antiderivative of 2? Put brackets in all three terms. -1 to 2. Trav, I'm scared. I can't do this one. Yes, you can. Upper minus lower. Go slow. Bracket, giant parenthesis. That negative stays there, guys, because that's in front of the x cubed there. So 2 to the third power is 8. So that's going to be a -8 thirds. Plus 2 squared is 4, but divided by 2 is going to be 2. Plus 2 times 2 is 4. That's the upper. Minus, open parenthesis. -1 to the third is a -1, but negative times a negative is a... So I'm going to have 1/3. Is everyone okay with the 1/3? And then -1 squared is going to be 1. And then so it's going to be a half. And then 2 times a -1 is going to be -2. Child, I don't know if I can do this. Yes, you can. I'm going to move all this to this little piece of blank space that I have there. So sorry that it's getting super busy here. So I see that I have -8 thirds, and then 4 plus 2 is 6. And don't worry, we're going to figure that out right now. And then this I can do pretty fast, or maybe not. 1/3, 1/2 minus 2, that I can do fast. That's -1.5, which is the same thing as -3/2. Okay, I don't see any errors. So here we go. I'm getting a common denominator. So I'm going to multiply this by 3 for this guy. 6 times 3, 6, 12, 18. 18 over 3. So I see this. -8 plus 18, that's a -10/3. Minus, and let's see. I'm going to multiply this by 2/2 and this one by 3/3. So I see, what's that? 2/6. Oh, yeah. You're right. I did that on purpose. No, I didn't. 2, 6 minus 9, 6. Okay, 2 minus 9, that's 7, 6. So minus a -7, 6. Did I do that right? All right, so let's see. 10/3 plus 7/6. So I'm going to multiply that. Yeah, I know. Look how cumbersome it is by hand. So 20/6 plus 7/6. So I see 27/6 if we did it correctly. We're about to find out. We'll do it real quick with a calculator just to make sure. I'm going to put this in the calculator from -1 to 2, and I'm going to see if I get a positive, and it better be positive, 27/6. Oh, yeah, because 3 goes into both. Thank you, Ms. Guerrero. 27/6 is the same thing as 9/2. So that's my answer. That's my final answer. Yeah. All right, here we go. Let's see. I'm just using the calculator just to check, guys. Math 9 from -1 all the way to what? 2. And what was my function? -x squared minus x or plus x? Oh. Yeah, well, -x squared plus x plus 2. Plus x plus 2. And I'm going to put an x here. I'm going to push enter. And I'm going to turn it to fraction. And yep, that is definitely 9/2. Good job, miss. Don't use this to cheat, guys. Sweat. You can use it to check your answers. Okay. Here we go. This one, we're going to do it with a calculator completely. All right. By looking at it, can you tell which one is which without the use of a calculator at the moment? I know we said with a calculator, but can you tell which one is which? Yes. This one right here, I noticed that it crosses the x-axis, and that looks like a -1 to me. So that one must be x squared minus 1. This one right here must be 2 cosine x. I draw a little vertical line to see how my slice looks. Which one's on top? 2 cosine x. I need to figure out these two intersections. So here's what I'm going to do. Don't worry, I'm going to use my calculator. I'm going to find out, I'm going to write 2 cosine x, and I want that to equal x squared minus 1. You need a calculator to figure this one out, guys. Type in 2 cosine x into y1. type in x squared minus 1 into y2. So look, here's my calculator. I go to y equals. Let me clear it. Let me clear my whole calculator. Second memory, 712. Y equals. What did I type in here? 2 cosine x. Close it. And on y2, I'm going to type in. All right, there it is. And you know what? For fun, I'm going to make the window exactly like this. That's an x. That's a y. Negative 3 to 3 and negative 2 to 3. So let me see if I can remember that. Window, negative 3 to 3. And then y was negative 2 to 3. Graph. There it is. Tell the calculator to find the intersections for you. Oh, the future will be like that because AI is coming. There's only a matter of time before there's a calculator with AI on it. All right, here we go. Second, calculate. Look at everything it can do. Use the number 5. Be careful with the number 7. I know some of you already know how to use it. Use the number 5. Push enter twice. And it's symmetric on the y-axis, so it's going to be the same value for the magnitude for the other one, but positive. There it is. It needs to say the word intersection. Do you see that intersection value? On here, I'm going to call it. Yeah. Push enter. It needs to say the word intersection. It doesn't?
No, it does.
Okay. X1, negative 1.265424. Negative 1.265424. Here's what I would do, guys. I'm going to store this into A. Here's how I would do it. You see that intersection? Right now, it is stored in memory as an X value. So if you go second quit on your home screen and push X next to the alpha and just push enter, look, there it is. Store it. Push the store button and put alpha A. You could actually done it over there in the first step as well. So there it is. So I'm going to use now the letter A on my calculator. You don't want to use the letter X. Cool or not cool? All right. Go back to Y. Go back to the graph. I'm going to find the other one. Obviously, it's the same number but positive. So I'm going to go second. Here's an opportunity to practice, guys. Practice. Second, calculate number 5. First curve, enter. Second curve, enter. You only have 2 curves. When it says guess, that means scroll to the one you want. And then push enter. And it needs to say the word intersection. If it does not say the word intersection, you have not found the intersection. Cool or not cool? All right. Go to your home screen. It should be the same number. Push X. It should be the same number but positive. So I guess the same magnitude. Store alpha B. I just go down the alphabet. Cool or not cool? All right. So let me put this here for notes, for good notes. How do you get what? Oh, push enter. And then the on button. And now it should that breaks the loading thing, and now you can push whatever button you want. Here, bring it to me real quick. Okay, I'll go over there right now. Oh, it's okay now. 1.265424, and then the arrow indicates that I'm storing it to B. All right, here we go. Ready? Integral from A to B. Which one's on top? 2 cosine x minus, put a parenthesis, x squared minus 1, close it, dx. And if you want to put a parenthesis on the whole thing, boom, boom. All right. Some of you are really bad with parentheses, and you will tell me this. Is that the same expression? No. If you decide to not put parentheses, then put a plus right there. Because if you distribute the negative, that turns to a plus. But some of you are really bad, guys. So put parentheses right there and leave that as a minus like that. And if it's a calculator question, you can leave it like that. And then just type the answer. Now look, be smart. You don't have to work harder. You have a calculator. I mean, yeah, you can go math 9 and then put the lower limit, upper limit. But look, we have everything stored, guys. We have it as y1 and y2. And we have the limits as a and b. So be smart. Look, on my lower limit, I'm going to put alpha a. On my upper limit, I'm going to put alpha b. Inside, when you get inside the parentheses, you can type 2 cosine x if you want. But don't I have that as y1? So just do y1. Push alpha trace y1, and I know there's other ways to get into y1, but I think that's the fastest way, minus alpha trace y2. Push enter, or don't push enter yet. You got to put an X right here. And boom, there it is.
I've been flabbergasted.
What is my answer? Yes, 4.9949. If this were an AP exam, you would write 4.994 or 4.995. Truncated or rounded, it does not matter. 3 digits after the decimal, thousand space, all times, forever and ever, unless otherwise noted. If you want to put more digits, put more digits. 4.9, I already forgot it, short-term memory. 9490. Okay. How do we feel? Okay. You have a delta. All you're doing is practicing. You're doing average value and you're doing area under the curve. Relax. It should be pretty easy. It's nothing straightforward. Just today. Do you feel overwhelmed? No. We did two subtopics in one. So that's it, guys. We're done. Good job. And let's take care of business.